All right, I'm Cameron Cochran. I've got 13 and 14. If you get any packets, I got a whole pile of stuff in there for you. First thing, this is Bidwell machine setup guide. Basically, same thing for any transverse screed, whether you have somebody popping up with a Bidwell, a Mako, or an Allen. They asked that we don't spread this around. They like their stuff. Didn't want it to get to their competition or whatever. So that's for your use. Hang on to it. You've also got a copy of this, which we'll be referring to in a minute. Keep that handy. You got a copy of the dry run procedures for transverse screeds. We're going to go through that in detail. Got a copy of something that looks like a spreadsheet that ought to be right beside your dry run paper. Then you've got a couple of checklists at the back we'll talk about later. Some of you have probably heard this presentation before. Some of the reasons we are doing quite a bit of review in the presentations this year is because we still walk up on projects and see the same things happening, so the message has not been getting through very well. There's several key points I want you guys to take away from this today, and one of them is the screed rail is the most important factor in how your bridge is going to ride. We're going to spend a good deal of time discussing this. And just getting some nomenclature out of the way, this is what I'm going to be calling screed rail all day long, what your screed's riding on. The carriage rail is what your bogie or your carriage is hanging on your screed. But this is your screed rail. I'm going to be calling these saddles or cups or something other, the little supports that hold the rail up. Two numbers to remember on all of this setup stuff is a 1/4 inch and an 1/8 of an inch. A 1/4 inch, if you make one complete revolution of that nut right there, it's going to raise or lower that rail 1/4 of an inch. That's going to be handy when you start getting in and doing your dry runs and you're trying to get that thing riding good. So remember, a 1/4 inch and an 1/8 of an inch. This is a 1/4 of an inch. So how much is a half a turn? Half a turn's an 1/8. Now, during this whole preliminary part right here, when we're talking about getting this screed set up, where is our bogie or our carriage going to be set? In the middle. We're going to start off with it sitting in the middle. Later on, when we start doing dry run, we're going to move it around. But for this entire beginning part of the setup, that bogie is going to be sitting in the middle. All right, what's this fella right? Well, hold on. Part of this gets neglected depending on the contractor that you have got. Some of them do a real good job of it, but the first few things right there, squaring the machine in, straightening the truss frame, things like that. A lot of this setup, depending on who you got, may or may not get done correctly. First thing you ought to be doing, what's this gentleman doing? Measuring what? He is measuring. Screed rail down here, and I already talked about, this is our carriage rail. On a normal pour, where you have got the bridge riding on overhang form, or side forms. On a normal pour like that, the first thing they ought to be doing is checking and making sure that that dimension is the same on all 4 legs. You'll have some situations we'll look at here in a few minutes where they're doing maybe a latex overlay or a rehab or something like that, where these legs over here are riding on the old deck, and the rails on the other side are riding on top of a barrier wall or something else. But if on a normal pour, you're going to have it set up with all 4 of these legs the same length. If you have one where, like I was just talking about, with an overlay or something, where you're sitting on the deck on this side, these 2 legs would be the same length. And on the other side, if you're riding on top of the rail, those 2 guys are going to be the same length. But get them the same length starting off. How is he going to change that dimension to get those the same? Leg screws. What numbers are you supposed to remember? 1/4 and 1/8. This right here, 1 full revolution's just like those nuts. 1 full revolution raises or lowers that leg 1/4 of an inch. Now and through this whole presentation, and I've said this every time I've given it, this stuff, the information that you're getting is not to make you some kind of telling him everything he's doing wrong when he's setting that screed up. This is to let you know when you're watching him, what is he doing and what effect is it possibly going to have on my pour. And it's also letting you know later on, by knowing this stuff and observing what he does, if he starts having problems, you guys are going to be able to give him some suggestions and know when he's making these adjustments, what are these adjustments doing? So if he's, if he's going through the core and all of a sudden he gets on his back legs and takes them up a half a turn, you guys know what effect that has. Okay, he's raised his back end an eighth of an inch. Why has he done that? What's that going to affect on the rest of this deal? So, what's this fella right here doing? Somebody in one of the classes said his belly's hurt. No. What this is supposed to be showing, next thing you do is you generally straighten your truss frame. Now, the whole big deal up here is your truss frame. And it doesn't matter if it's perfectly straight or not. You want to get it roughly straight. You've got a pin that goes through the bottom and either an all thread, or right here's a manual crown adjuster that goes through the top, and you want to get those fairly straight. That's not where the big deal is on your cross section. Here's where your big deal is. There's your carriage rail I was talking about earlier. That right there we want just as straight as an arrow. In order to do that, at each of the corners of his truss, he's got an eye bolt. And that's what this string right here is tied to, is that eye bolt. You pull that string just as tight as you can. And then at each of those corners, he's also got an identical block of wood to that right there. You set that block down on top of your carriage rail, pull your string up over on top of it at all four corners, and then you go down to each one of these adjustments. And you adjust the carriage rail in between until you can barely fit that block under there. After you do that, you ought to be able to get down at the end of that carriage rail and look down it, and it ought to be very straight. That is what is determining the cross section that you're putting into that deck. So that's the part that has to be very straight, not the whole big truss frame itself. Now, where again is the carriage while we're doing all this? Sitting right in the middle. Okay. Now we're going to start talking about some more of the nuts and bolts on here and how we're going to set those. All of your screeds are going to have rollers. Some of them may or may not have rotovibes. You're going to have augers, depending on what type of mix you're fooling with and what you're doing. Maybe drag pans and burlap. Should be most of the time. Maybe not. I was talking about different types of screeds. The only Allen screed I've ever seen, I was talking to the rep. They just bought the screed. He's out there setting it up, and I was asking him about the screed. If you got these different things, he said, "You got rotovibes." He said, "No, Bidwell's patent hadn't run out on those, but we'll have them soon." So, any of these things that other things are going to be the same, whether it's Gomeco, Allen, Bidwell, whatever. All right, what's this fella doing? I need to get a better picture of this because I don't particularly like exactly what he's doing. But what he's doing right here, he's got a stick rule. There's his drums, there's a 4-foot level, and there's a string right here. We want to get our drums squared up. The reason I don't like this picture is over time, when you're using your drums and when you're using those augers, they get worn down. And it's more obvious on augers normally. They don't replace them nearly as often, and they start getting tapered. So you guys need, when you're checking this, you need to have this 4-foot level underneath out here at the end, because that's the part that's actually touching your concrete. And if those are old worn drums, then you may not get a true picture by putting that on top. We want them on the bottom. So what we're going to do is this string up here, he's got it on the carriage rail on each side. And he's measuring down from that string, hopefully to the top of the level, which is tucked up underneath the end of his drums. At all four corners, we want the same measurement. Now, they may say we just set this thing up on the last job, it was fine. Maybe it is, maybe it isn't. Doesn't take long to check it. And Aaron, I think, was talking about one the other day where he had some finishing problems and suspected one of the drums was set higher than the other one. So we want them both set to the right elevation. Now, the easiest way to do this, everything doesn't really line up under there. You've got Looking at it from the top, you've got your two drums. And I think the rotavibers may stick out here, and they're offset a little bit, and your augers they're offset a little bit, so you can't really. Actually, the augers are on the inside just a little bit, I believe. But you can't really set that 4-foot level under there and run straight out and still be directly under your auger. So the easiest thing I think to do is probably you take 4-foot levels, you put them underneath the two drums, and then you can just take a string and pull across the top of the two levels to set these augers, to get those to the right height. And like I said, for right now, we want all four corners, front and back, we want those all the same dimension. We're going to change that a little bit later, but right now we want it all set up the same. Now, Rotovibe, talked a little bit about that. Some people love them, some people hate them. How many of you guys have contractors that use them? What's the purpose in the thing? We've already vibrated the concrete, or you should have. What's the purpose in that Rotovibe? What's this guy doing? He's the one that's already vibrating it. But which way is he going, you think?
Vibrated down in the steel.
Well, we'll imagine he's got a little more mix in there.
Yeah.
Which way is he going? He's walking right through what he just vibrated. That Rotovibe is supposed to be taking care of the, getting that top that everybody's been walking in consolidated again. They don't have to have the thing, and I don't care if they do or not. But if they don't have it, then I spend a lot of time going back and saying, no, you got to go back and vibrate where you've been walking in it again, aggravating them like that. If they've got them on there and they're working, I don't mess with that. But that is the purpose of it, is to reconsolidate that top couple of inches above your steel that everybody's been walking in. You can tell this one right here is an old one, and they made some changes to them because they're, especially on a skewed deck, these can cause problems. The old ones have got fins on them like this long. And if you're on a skewed deck, you're setting your bogey up parallel to center line, and it kind of squeegees across through there, and it can mess up your finish, tear your mat. And it can also, I saw one the other day, pushing a whole lot of mix. So what they've done is they've gone back, and the newer ones have just got basically nubs on them, a little ridge on it. If a contractor's using one, and you're on a skewed deck, and we'll talk a little bit later about a couple things on skewed decks, but if he's having trouble out of these on a skewed deck, then the easiest thing to do is, there's two of them. The leading one over here, the one on the lead edge on the finishing pipe, which we're going to talk about in a few minutes, finishing pipe, raise that one up to where it's not causing you problems, and leave the other one down, and that should take care of the problems that you see. All right, crowns and transitions. This is something roadway design throws on us. All kinds of nasty problems and setting screeds up come out of roadway design because of the geometries that they give us. And all of them we can pretty much deal with, except where we've got a crown and a skew in combination. We'll talk about those a little bit more later. A vertical curve and a skew in combination is one that we can't deal with. All right, when we're setting a crown in this thing, so far we've got this thing set up. All four corners, we got them the same. We got the carriage rail straight. We've gone in, we've checked our drums, made sure everything's square there. Well, if we got a crown in the deck, then here's where we're going to set our crown. And for right now, we're assuming we've got a nice little 90-degree pour with a crown in it. This is a manual crown adjuster. And over on this side, you see there's a big sprocket here and a big sprocket here. There is a pulley here with another, sprocket here. It's got another chain goes across. He can stand right here and adjust both sides at once when he cranks that knob he's got right there. This is one of the only places you're going to have to worry about 1/8 of an inch. Every rotation he makes on what he's cranking on right there, on that manual crown adjuster, is going to raise or lower that point 1/8 of an inch. So how do we set our crown in there? Well, we know what our elevation is here. We know what our elevation is here. We know, we pull out the old surveying book, whatever you want to do, And we know that there's a straight grade in here somewhere between these 2 points. And we need to figure out what the elevation is on that straight grade right here. We know what this elevation is right up here, and the difference in those is how high we need to be on our crown. You can do it a couple of different ways. Pull you a string line from here to here and go to here and measure that distance up. Or you crank it in, whatever you want to do. You want to count the cranks and however many inches you've got to go up. But anyway, that's how they're supposed to get it in there, and that's how you should be checking it, is from here to here with a string line, and then measure it from your string line to whatever the same point is out there at the middle and make sure he's got that right. Now, we haven't even talked about setting anything to grade yet. That's where we're at. How do your guys usually start setting the machine to grade? First of all, I want to know, well, what do they use to set the machine to grade? Where are they starting off at doing that?
At header at the end of the bridge.
At the header, where are they setting their header grades from? Should be build-ups. One of the things I want y'all to remember out of this is everything you set and everything you check from deck pans on through the pour needs to be referenced back to the build-ups. Not off of something else you've checked off the build-ups, not off of something right before that you checked off the build-ups. Everything goes back to the build-ups. It's just like going back to a benchmark. Taking everything back to the same place and eliminating some errors. We'll talk about that in a little more detail later. Another question, how low do your contractors, how low do they usually set the header?
A little bit lower than what it's supposed to be so it would clear it. It's a bit low.
That's what I always used to see. You know, they go through there and set their header, and then they put a few nails in across it, and then just like a 1/4 inch up. When they run that screed across through there, if they heard it squeak on the nails, that was good news. They thought that was great. I don't particularly like it. I want my headers to be about that much low, and the reason I want it that low is because I don't really care what's happening right there. I want the machine to finish that header. We're going to look at some cases in a few minutes here where we got some troublemakers. If we set that header just a dab low, it looks nice and we think we've set everything up good, but you got a guy that's more than likely going to be coming through finishing down through here, and what's he tempted to do?
He's going to finish to the top of that header.
He is tempted to finish down to the top of the header, which is going to leave you with a bump. We need to make every effort in setting these things up to make it to where we have to touch it as little as possible. I don't want a guy finishing on that header. And if there is a guy finishing on that header, if you start off with a rough texture or something, if it's a couple inches low, just about everybody can figure out, well, that's 2 inches. I don't need to be finishing down that much. But if you're just a little bit down, he's going to be tempted to finish down to it. I want him to leave it to where maybe they got a little foot-wide piece of plywood across the top of the header right there. They can let the concrete just roll off. Next day they can come in and zip that off with a quickie saw or something. And hopefully nobody's had to touch this. And if they haven't tried to finish down to a header. But just watch it. However they want to do it's fine. But if they do have it just a little bit low, you guys need to be watching and making sure that they're not finishing down to it. And as soon as that screed gets far enough out on the pour, somebody needs to be out there with that 10-foot straight edge. And they need to be checking both this way and this way to make sure we're starting off right. Especially checking, in the situation I'm talking about here, checking off that header to make sure that they haven't finished down to it. A whole lot easier to fix that green concrete than it is something that's set, like Larry's going to be talking about this afternoon. Okay, but hopefully they're going to come through there and they're going to start setting those drums off of their build-ups. They'll come out to this exterior girder and start measuring down deck thickness plus build-up to that drum and crank these legs both the same amount until they get right. Come over here to this side and do the same thing. That ought to get them started off pretty good. Okay, now you got some printouts, one of which looks like this. Pull it out. 2 pages. This has basically some information out of the slides and some stuff that you probably also have a copy of in this big machine setup guide. It's also, the second page is troubleshooting stuff. If you start seeing stuff happening on that pour, something's not going quite right, you've got the troubleshooting guide, you can say, well, what's possibly causing that? Here's just kind of a cross section of our screed. which point, we just talked about setting some grades on this. Which point do we set first? We just pulled up to the header and we checked off the build-ups and we set this one right here first, didn't we? We want this point right here at the finished grade level of our deck. Now you can see these other numbers on here, 1/4 to 1/8 above, 1/8 above, 5 to 7 inches above. I don't like the way these orders went, so we're going to skip on through these little dots and stuff. But we're going to set this one first. Now which one do you think I ought to set next? What? This one? That's where I'd go. Why do you think we ought to do that one first?
You want to control your header. I mean, you want to control your rolls first, right?
Well, all right, let's get into how are we going to get that 1/8 of an inch in there. How are you going to raise this in 1/8 of an inch? Are you going to monkey with your drums? Going to monkey with your rail? Jack your back legs up a half a turn. Now, the reason we're going to go here next is if I go out here and I try to set this first, and I go back here and jack these legs up, what's happening out here? Right. When you mess with these legs out here, it's all pivoting around this point. So I raise these up, this end goes down. So you're just backing up. You'd have to go back and check this again, end up adjusting again. So we're going to set this one, then we'll come back here, put the 1/8 of an inch in our back end, and then we'll come out here and check this one. I already told you take 2 levels, put it on the bottom of the drum, pull a string across it, and set these. All these are just rules of thumb. And depending on your deck geometry and your mix consistency, you may have to make some adjustments to this. If you're pouring uphill, if you're on a nasty little super elevation, if you've got a 3-inch slump versus a 4-inch slump, things like that are going to make a difference in part of these things. These are just good rules of thumb. You don't need to be out there, like I said, making him change stuff just because it doesn't match up to what you've got on the printout. But this is to make you aware of what all this stuff is, what effect changes have on it, and to try to help him out if there's problems. So we're going to raise our back legs up, put 1/8 of an inch in here, then we're going to come out here and check this. I would check both ends, front and back, because we already talked a minute ago about as you use these things for years and years, this end starts getting worn down and starts getting pointed, look like a Christmas tree or something. So make sure you check both ends just to make sure that you don't have this one set right and back here you're at or below grade. So check both ends of it. Back here on this drag pan, I wouldn't worry about that, except that there's one thing I want you to remember. These drag pans, and we'll look at some pictures in a few minutes, they go on in a certain direction. The bars, there's bars that run across the top here. There's a ring on the bars, and the chain's connected to the ring. That's what they hang on. Those bars are only supposed to be going in this direction like this, end of the page. The bars don't go front to back. Depending on your deck geometry, if you get it on there wrong, it can cause trouble. It doesn't let the thing slide back and forth all the way like it's supposed to. And I've seen a couple of pours where they didn't have it on there right, and the corner got dug down in and was going through like a snow ski or like a water ski through the deck that we'd already finished. So just remember it goes on, and you're talking 50-50 chains. Whichever way they grab it's normally the way it goes on there, unless you've talked to them before and told them this is the way the thing goes on. And if you got those rotovibes on there, they ought to be set to where the little bottom of the ribs is the same elevation as grade. Okay, what are we looking at here? All right, right here, that's what he raises and lowers his augers with. He should have a pin. I don't know where. There should be a pin that goes through here, through one of these holes into a hole in this piece of steel right here that keeps that thing from vibrating around and moving during the pour. He needs to have a pin through there, but that's what he raises and lowers his augers with. This right over here, what's that? That's his vibrator control for Rotovibes. He can turn up the frequency on his vibrations right there. And it makes quite a bit of difference too. This little knob right here is what they raise and lower those Rotovibes with. If the thing to remember about Rotovibes is if they have them and are using them on that screed, if you get a space between trucks or something happens and they have to stop for a little bit, there's a switch right up here, a lever. It doesn't turn the bogie motor off, but it takes it out of gear. If they have to stop, pop it out of gear. They don't need to be sitting on the same spot just to vibrating. Really, even if they don't have a Rotovibe, they don't need to be sitting on the same spot spinning. So if they have to stop for any amount of time, make sure they flip that lever and take it out of gear. Okay, in your big handout, this is actually 3 different pictures out of your big handout, combined on one slide. Couple of things to be looking at. Right here, these things are made to carry about a half an auger height of material in front of the augers. What do you normally see on the deck core though?
Raking it back.
They raking like mad. They think, if I'm not raking, boss is going to think I'm not doing anything and I might get in trouble, so I'm going to rake. And they'll, I don't really care about that until they start raking too much out, and then they start pushing it back, and they're just, it's a back and forth thing. They don't really need to be doing that unless it starts getting to an excessive amount. Half the diameter of the auger is what the thing's made to push. Right, the roll that you're leaving on the finishing pass right in front of the drums, ideally they say it's supposed to be like a golf ball size roll of grout. You start pushing too much grout, you start getting into an open finish. You've all seen places where it looks like there's just spots where you don't have any grout on top. And that may be the culprit right there, is you're pushing too much material with your augers. If you don't know, there's a left hand and a right hand auger. And if you get them on there backwards, you'll figure it out pretty quick. Because all this mix that it's pushing ahead when you got them on the correct side, it's going to be sucking back into here if you got them on the wrong side. And it's going to flood your drums and make a big mess. I've seen one time where that, at least where that's happened, they got the augers on backwards. Okay, this right here is one of the points I want you guys to remember. We're going to start talking about finishing passes and traveling passes. And I want you to have it clear in your head because it's very important when you start getting into how this thing is functioning and if you're getting a good finishing job out of it. As you know, you can set these things up anywhere in the world. You can have them both turn in the same direction. At the end of the pass, you can have it where the drums spin the other way as they go back on the pass. You can have it set up like this where drums turn in the opposite direction. This one right here, the only time we should see a setup like this where both of your drums are turning to the middle is if you've got a 90-degree skew crown deck. That's the only time we ought to see that. If you're on a skew or you're on a super elevation, both drums should be turning in the same direction. Anybody want to take a stab and tell me what is a traveling pass? Or what is a finishing pass? Okay. For this example right here, this clockwise example, if my bogey is traveling in this direction, this right here is a finishing pass. And you're going to end up with a roll of grout on this side of your drum. It looks, if you stand back and look at it, you remember the old westerns where the stagecoach comes into town, it looks like the wheels are turning backwards? Well, the bogey's moving this way, and it looks like those wheels are turning backwards from the direction it ought to be turning if it was a little car or something. So the grout builds up on the leading edge of a finishing pass. If, in this clockwise situation, my bogey is moving in this direction, those drums are turning like this, that is a traveling pass. All it's doing is traveling across. It looks like the wheels are turning in the right direction on the stagecoach. So, that's going to be important, and that's something you need to look at during your dry run. Which way have they got the traveling pass and the finishing pass going? It's especially important on a skew, and if you get it backwards, you're probably going to make a mess. That ought to be one of the questions these guys, or Kevin, or Lee, or Darren, whoever, when they come to that pre-pour meeting, that ought to be one of the things that they're looking at too. You got a drawing that looks like this, which I think may be, let's see, that's on the back side of that, of this 2-page handout. As I said, it is probably more important than anywhere which direction your pass is on one of these skewed pours. Which way do you think you're supposed to be going? Which way do you think your finishing pass is supposed to be going? I'll give you two choices. From leading edge, you got you're traveling in this direction. You're moving in this direction right here. This is your leading edge. It's out front. There's your trailing edge. Are we going to be going from leading to trailing, or trailing to leading? Huh?
Leading to trailing.
Leading to trailing. It says finish from leading end of machine to trailing end of the machine. So that's right. But what's this note right here? So the normal procedure is to finish from low side of the deck to the high side of the deck. Well, that's fine and dandy in the drawing they've got here, but what if this over here is the high side of our deck? We're in a super elevation, that's our high side, and this is our low side. It's saying finish from low side to high side, going in this direction. But this note down here says go from leading edge to trailing edge. Which one do we think should go first? Which is going to supersede the other? Y'all ever seen the movie Raising Arizona? Had a bank robbery scene, and he jumps in and says, "Everybody freeze! Everybody down on the ground!" The old man starts going, "Which one you want I should do? You want I should freeze or get down on the ground? Because if I get down on the ground, I'll be in motion, and I can't rightly freeze." That's kind of the situation you're in. What you remember on this is we're always going to go with this one right here, from leading end to trailing end. Whether or not we go in the proper direction as far as low side to high side, that is secondary. What you're going to end up with is if you finish from a high side to low side, you're going to end up with a whole lot more grout down in this gutter line as you're finishing than you would if you were finishing in the other direction. The reason we want to do it like I'm talking about here is, all right, let's imagine the drums are basically acting like a big squeegee, right? Okay, if I take my squeegee and I hold it like this, and I start doing this motion, where is the excess, if that's my windshield, where's the excess water going to be going? If I start doing like this, where's my excess water going to end up? It's going to start rolling back like this and spitting out this side. If I do the opposite, and I take my squeegee and I start pushing it like this, that excess is going to start rolling off this end. Well, I've already got this stuff back here finished. I don't want that roll going back here. If I do that, I'm going to end up with ridges coming out the back side of the drum. If I'm moving it like this, the excess is going to be spit out the front. I've not finished out there yet. I need some grout out there anyway, so that's what I want to happen. So we're always going to finish from the leading edge to the trailing edge. And if you get it backwards, it'll probably be obvious pretty quick because you're going to start spitting that roll out the back and you'll have little ridges going all the way across your deck. What this drawing is also showing is there's a skew bar kit on here, and we'll get to a skew bar kit in a minute. But the main thing I want you to get right now is you need to know which one is a traveling pass, which one is a finishing pass, and make sure you got it going in the right direction on your report. The finishing pass needs to be going this way, traveling pass this way. Another thing to remember on these skews is the worse the skew is, the less finishing area you really got on that drum. And I'll show you that in a few minutes, but the point of the story is the worse the skew is, the less you ought to be advancing between passes. You can advance more on a 90-degree skew than you can advance on a severe skew. because you're getting less finishing area out of your drums. Okay, dry run, grab that sheet. Look at note number 2, it's to be recorded in the workbook, not on a legal pad, napkin, notebook, paper, donut box, or anything else. You all got workbooks. They give them away at the residence office every day. They're free. They got plenty of pages in them. Use them. Don't put it on a legal pad. Those things tend to wander off. You've got in there right behind your dry run procedures sheet, you got this nice little setup. Tell you how I'd like to see mine set up anyway. Using a whole page for each girder. Going to be training my guys in about 2 weeks, and I'm going to be telling them the exact same thing. I want it in a workbook in your hip pocket when I get out there to that deck port. I don't want it on a legal pad in the truck. And you need to have this work done, which was going to be the work that you do during the dry run. During the deck pour, these 2 things down here, depth checks and cover checks, need to go in that workbook too. You need to leave enough space to where I can, when I'm out there checking depth during the pour, I can look around and say, okay, I'm at about the 3rd 10th point, and I'm over here next to whatever, girder 4. And I can go into my workbook where I've already done my dry run, and pretty close to there, put these dimensions in. What I usually get when I ask an inspector, how'd your dry run go? Dry run went good. He's out there. I say, how's about your depth checks? Depth checks went good. What were they? I don't know, but they went good. I said, doesn't help me out. What, you know, if you can't tell me what you actually got, we don't really have any good information. Cover checks the same way. All right, grab that sheet. Part of this stuff we have, okay. How are your guys setting the grade on that screw grill? Got some metal decking in here. How are they setting grade on this? Somebody. How are they setting the rail? Okay, how are they setting their overhang grades? We'll go there. How are they setting their overhang grades? Preacher? From where? Preaching off the build-ups. I've actually seen people try to preacher off of the metal decking. They think it's going to be easier because they say, okay, that's the bottom of my deck there, that's the bottom of my deck. I'll build me a little jig with plywood, and I'll make this jig like this and put me this big long 2x4 in here, and I'll measure down off that jig, and that's how I'll get my build-up. Get my overhang. Don't do that. What I tell you already earlier. Everything that we set, everything that we check, we should be going back to the buildup. All right, we have a subcontractor come in here, whether it be Height, Mason, Ace Steel, Border Rebar, whoever. They come in here and install this metal decking, going by the buildup grades that you've marked on top of the beams. Are they going to do it perfectly? No, they're not. So let's say they've got, they mess up a little bit and they've got a 1/4 inch right here. We'll call that X. They're a 1/4 inch off right there. Okay, let's say that somebody comes off that decking, like I just showed you there, and they try to set that overhang grade. Are they going to get that perfect? No. They're going to have another angle, another area out here. We'll say that's Y. They got another 1/4 inch off. How are they setting this rail grade? Some of them are just trying to measure up off of here. That's, that's okay for preliminary. But when you're checking, that's not. We need to be going back to the build-up, because when I measure up off of here, am I going to get all those perfect? Nope. I'm going to have another little error in there. So when you start adding those 3 errors together, they're compounding each other. I messed up a little bit right here, and I set this off of that, so there we got those two errors in there together. By the time I get out here, I may have 3/4 of an inch if I have a 1/4 inch off on each one of those. We do not want to do that. Everything you do, go back to the build-up. That's your benchmark. Set every single thing from the build-up and it will minimize the errors. And when we start checking this during our dry run, that's what we're going to be doing, checking to the build-ups. And it says right here, if he's just wanting to get in the ballpark, that's fine. He can measure up, but that is not going to be the final word on it. We're going to check it to the build-ups and set it to the build-ups before this is over. Part 2 right here, we've already done this. We've got our screed squared up. Got everything, all the legs are equal. We've done all this already. Now, there's 2 ways that you can do this dry run. I don't care which one you want to do. You can stand up or crawl around on the rebar. Doesn't matter. Look on the back of that sheet. You got a cute little drawing. The part that we are interested in is right down here. Now, after we get this screed set up, there's nothing really going to change between here and here, between our carriage rail and actually right here. Our carriage rail and the front of that roller. Nothing's really going to change. There's no moving parts in there. Some screeds have got the little thing where you can raise the bogey, but it goes back down to the same place. So nothing's changing in there. So if I know that distance from the carriage rail down to that drum, well, I know what my deck thickness is supposed to be, and I know what my buildup is supposed to be. So I can go through there, if I want to, measuring down from this carriage rail to the top of my girder and stand up all day long doing this. Or if you don't want to do that, or if you're having trouble with that and want to double check, you can always measure from your drum down to your buildup. Either way, it doesn't matter. But if you look at the sheet I gave you, it looks like a little spreadsheet. Like I said, I know my buildup, I know my deck thickness, so I know the number that I am looking for during this dry run. And I'm going to force it to give me that number. Okay? Now, as we go through this sheet right here, at some point, somebody should be saying to me, that's crazy, you can't do that. Thank you. This sheet right here, somebody's going to ought to be saying, that ain't right, you can't do that. So let's see who picks up on that. So if you look at that sheet, look down on, say, build up number 2. I know my deck thickness is 8.5 inches. I know I got 1.6 inches on my build up. So I should have 10.1 inches when I check that dimension from the front of my drum down to the top of my girder. If I don't have that, I'm going to adjust the that screed rail, the rail that the whole truss is running on, until I get that number. I'm going to make it read, if it's reading 10, I'm going to make it read 10.1. That is what gives you the ride. Okay? Now, when I do that, well, let's take it a step at a time. When you do that, this guy right here, he's doing what I was talking about a while ago. He's wanting to stand up the whole way. He's got a string running from carriage rail to carriage rail, and he's measuring down again to get that constant distance. Now, after he does that, he can just go through here and measure from his carriage rail down to the top of his girder, and he knows the constant, knows the buildup, knows the deck thickness, and he can go at each one of those places and make that rail give him the number that he wants. Now, when you do this, there's a lot of things changed, at least in things I see in the last 15, 20 years. But used to, when people were doing a dry run, they'd go out and check all the number 1 buildups. Go back, cross over, check the number 2 buildups, and on through the deck it went like that. That's not what you want to do. We want to start off on the exterior girders. Go over to one exterior girder. And I'm going to go all the way down that thing with my book. And I'm going to, on each buildup, I'm going to check it. And I'm going to make it read what I'm looking for. I'm going to make it read deck thickness plus buildup when I measure from the bottom of the drum down to the buildup. all the way out that exterior girder. Then and I've got my bogey over there now. Wherever I'm checking depths, that's where I want my bogey. So I've got my bogey pulled over on top of that exterior girder. I'm gonna go from one end to the other checking buildups on that. I'm gonna take the bogey, move it to the opposite side of the deck, the other exterior girder. Come back down that side, and I'm checking each one of these buildups again. I'm never gonna check anything in the middle until that point. Because anything you do on those outside ones, when you start messing with this rail right here, and you're raising or lowering it to give you that buildup plus deck thickness, it's affecting everything happening out in the middle. So why do I want to go looking in the middle until I get these two outsides fixed? So you go out, down one exterior girder, back up the other exterior girder, and when you start checking in the middle, the only problems you ought to find are going to be one of a couple of things. Like we said, they had a little bit of error right here and didn't get the deck pan on right. Maybe they've got the wrong chair in there or the wrong size of rebar. Something we were talking about last night that I hadn't really brought out before is if you have something where you don't think it's going right, one of the possibilities is, all right, I've got a bunch of girders out here. Here's my exterior girder. If you look at your camber tables, are all the cambers for all these girders the same? Most of the time you're going to have a different camber for the exterior girder than the interior girders. So another place you might see something, if you get those two exterior girders checked and everything's good, and you start going to the middle and you get where it's consistently looking shy, you need to go back to your camber tables and make sure that, you know, when I pour, this one may be going down more than this one. So I might not really have a shy deck, it's just that my camber table's not, you know, there's a difference in the camber that's going to come out of them, and that may make up for that little bit of difference I think I'm seeing in the dry room. But like I said, if you get those exteriors taken care of, you should, everything in the middle should work out pretty good. All right. Nobody see anything weird yet?
I do. Crazy. What are you talking about?
This is just the math behind what I was talking about a while ago. You've got B's your build up, C's your constant, S is what you measured from carriage rail down to the top of your girder, and D's your deck thickness. You can do the math, look at that later if you want to. What's this mess right down here?
That's crazy.
Anybody gonna get within a 1/16 of an inch? I put that on there on purpose. And every time I bring this thing out and show it to a contractor, I say, you can't do that. I'll say, yeah, I know that, but here's the reason behind it. What does your spec book say when you run that straight edge after you're finished? What does the spec book say your tolerance is when you run that straight edge? What?
1/8 of an inch.
1/8 of an inch in how far? 10 feet. Okay, if you got buildups 5 foot apart, if you don't get within a 1/16 on 5 foot buildups, you're never going to get in 1/8 of an inch and 10 feet. That's the only reason that's in there. Point of this is you get as close as you can. I mean, you start looking at 1/16 of an inch on top of a concrete girder, as rough as those things are, I know it's not going to happen, but you want to get as close as you can. The part that is really important is consistency. Let's say right here is your theoretical grade that you're supposed to have on that deck. And I'm going through there, and okay, I check my first build up, I'm right on the money. Second build up is right on the money. Third build up, I'm a 1/4 inch low. And I think, well, that's just a 1/4 inch, no big deal. Next build up, I'm off a 1/4 inch again up here. And I think, still just a 1/4 inch, no big deal. All right, 1/4 inch off right here, and I'll get back on the money out through here. What have I got right here? You got a 1/2 inch knot in 10 feet right there. That is not acceptable. If all of these are just a little dab high, that's fine. If all of them are just a little dab low, that's fine. What I don't want to see when I go out there and get the dry run book from my inspector is this mess right here. I want it consistent, and I want it to be as close to that line as possible. My definition of close and your definition of close or the contractor's definition of close may be variable, but I want it as close as possible. Okay, And the rest of that sheet on there, you know, it's already told you how to check the build up at one point, go all the way down the exterior girder, back down the other exterior girder, and you ought to be in good shape. Hang on to these, pull them out before the deck pour, and use them. Put it in a workbook. Do not put it on anything else. Don't skimp and try to cram it all onto one page. Like I said, them things are free. They give them away all the time. Use as many pages as you need to make it nice and clear. And you ought to have it in your hip pocket during that deck pour. While we're on that subject, if you're the head inspector out there, where do you need to be?
On the deck.
On the deck. There should be plenty of people out there, and I guess I'm talking to residents now. If you don't have enough people who need to stay on the deck all the time and somebody else can run tests, that's not right. He needs to be able to stay out there the whole time and watch that deck pour. I don't know how many times I've stood out there by myself looking around trying to figure out where the inspector's at. And, you know, I don't know what it is about air pot, but you bring an air pot out and it's just like everybody's over there who got to see what's going on. Let somebody else do that. The head inspector's job is to have that book in his pocket, depth checker on the other hand, and he needs to be out there where the concrete's going down the whole time. As I said, you're doing the depth checks while you're doing this. How many depth checks do you need to do? My personal opinion is I'm telling my guys I want a minimum of 15 depth checks. I want depth checks done at the quarter points and headers, and I want a minimum done toward this exterior side, toward this side, and one in the middle. That's 15. Depending on the length of your pour and your geometry and other things, may want more, may want less, but they need to be recorded in that book, both depth checks and cover. That little T on the top of that depth checker that Mr. Leeds has got here, that's not a handle. That is what you're supposed to be checking your rebar depth with. Checking the cover over your rebar. Turn it upside down, poke around till you get the top mat, and see how much depth you got over your rebar. It's a whole lot better of a check doing it like this than waiting 2 weeks later and bring your M&T guy out with a packometer trying to see how much cover you've got. Much more accurate like this. If we start having deflection problems, over deflection, under deflection, we need to know how much cover we actually got out there. Just because you had it in a dry run does not mean you got it after they get this thing loaded.
Just a point, we were talking about this yesterday. I had some inspectors that they would check. They had a ton of depth checks. They would check the exterior girder every 10th point. So they were testing. I mean, they were doing all kinds of depth checks. But they weren't checking anything out in the middle. And we were talking yesterday. That screed rail is riding on those exterior girders. So if it deflects less than what it's supposed to, the screed rail does too. So it's, you know, that exterior girder is going to pretty much always be right. If it goes up or down, your deck thickness stays the same. But if your interior girders deflect differently than they're supposed to, than the exterior girders, then you could end up with problems out in the middle. So you got to be checking out in the middle too.
Another thing, try to remember, if you've got, let's say you got right here is your center line, and that's where your crown's at. The deck's going to be doing like this. What's that deck pan right there doing? Deck pan's in there just somehow flat in between there. So keep an eye on where you're taking these depth checks. If you take it right here, it may look just fine. If you take it right here, it may look like it's deep. So mind where you're taking those depth checks.
Try to take them where you took your depth check during your dry run too. And
Yeah.
record it right next to your workbook, same spot, as close to that 10th point as you can.
All right, we're going to look at some pictures now. Who's this fella back here? He's a troublemaker. I was talking about him earlier. What's he doing? Why am I calling him a troublemaker? He's just back there trying to make a living. You see anything he's doing wrong? What I would like to see is a straight edge about this long. His job, you know, this is the one part where we got to have somebody hand finishing. Your screed will not finish all the way out to that. But what he needs to be doing is he needs to be carrying the rate that screed is giving us across through there all the way to the gutter. And with a little old 2x4 like that, he's probably not going to do a good job of it. Probably going to look something like this. Now, we need to be watching him, and we should catch this. We should, when we're telling them, get your 10-foot straight edge out, I want to look at this, we should catch this. That's why the head inspector needs to be out there on the deck the whole time. He's got a whole lot of stuff he needs to be doing. He does not need to be fooling around with a slump cone. He needs to be out here checking all this stuff. Why is that a big deal to us? Why do we care whether he's got that gutter line finished just right? Well, there's a thing called spread that people in hydraulics spend, people in our hydraulics unit, they spend hours worrying about spread. Spread's like the boogeyman. That and scour are the boogeymen in hydraulics. Spread is how much, when we get a bad rainstorm, how much is this water in the gutter line building out toward the lane? And if you've ever had a bridge where it's got this big old wide shoulder on it and you see no sense in it, and you don't have any deck drains, that may be why. It's because they're worried about how much spread. You get that spread out in the lane and people can hydroplane. This right here, that's a path the water's taking. It's the same deck as this right here. He didn't finish it right, so it's forcing the water out into here. It's not following the gutter line. In a bad situation, that could force it all the way out into here, into the travel lane, to where it may cause somebody to wreck. So keep an eye on that guy. Okay, let's look at what's wrong with these pictures. What's going on here? See, and some of these don't show up as good on the big screen as they do on the computer, but can you see anything looks a little odd here? If you can see it, there's a pretty rough finish back here. You get out there in the sunlight and it's hard to see, but in the shadow you can kind of see there's a pretty rough finish right here, an open, pitted looking surface. You've all seen it. You know, why do you think that might be happening? What are some possibilities?
Say your vibrator
All
earlier.
those going,
Didn't you say your vibra temp earlier was cutting some of it off, or it might be buried in the front?
It could be. Does that look like a golf ball size? This is a travel. This is the finishing pass is going this way, so the rolling grout's over here. We can't really see it, but I'd say he's got too big of a rolling grout he's pushing. And when you do that, you start. I watched one just the other day. You watch the way the concrete moves when it starts pushing too much concrete along those drums, and you can kind of see why it does it. But it's leaving an open surface because he's pushing too much mix. Now you guys are smart. You've got the knowledge now. What can we do to take care of that? What should you see him do if he starts pushing too much mix and leaves a bad finish? He needs to be doing something right up in here. He needs to be adjusting those augers, probably. If he's pushing too much mix, maybe he needs to lower his augers a little bit. Keep a little bit more of that mix from getting to his drums. And while I'm on that, don't ever be afraid to just throw your hands up and say, stop, we're going to back up and see what's going on here. I had a poor month or two ago where the contractor, he's gets started off, it's not finishing just like he wants it to, so he says, I need to lower my augers, or I need to raise my augers. He wasn't getting enough mix. So he cranks on his little handle I showed you a while ago, moves ahead a little bit, and things get worse. I said, Pete, did you not raise your augers? Yeah, I raised them. I'm going to tell them to raise them again. So they go over there and do the same thing again. He keeps moving along. It gets worse again. And I finally said, just stop. Just pick it up, and we're going to go back to the header and see what's going on. Got the 4-foot level out, and I'm holding it up there, and Pete says, told his guy, raise the augers. Well, he starts cranking on it to raise it, and the auger starts going down. And apparently, and it's a brand new screw, but there's apparently those little stickers that go into that knob, there's different ones for different models, and somebody at the factory had slapped the wrong sticker on there. So every time he thought he was raising the auger, he was lowering it. Moral of the story is, don't ever be afraid to say, just stop, this is not good, this is not acceptable, let's back up a little bit. And when he did that, and he got those things adjusted right, he went back, backed up just a little bit, started finishing, and it went just slick as a whistle. It's not that big a deal to pick screed up, move back, check things out, and go back at it again. Anything else you see there you like or don't like? I kind of like these things. I've never seen them before. But that's a fogging device. If you can see it, this I told you before, little bars on the pan go this way. That's the way that they're supposed to go on when you hook it up.
Where does that get its water from, that fogging device? Yeah, does it carry a tank on the screed?
It must be up on the truss.
It does.
There's a hose right there going. Looks like it's going up the truss. That way they go.
That's something too to be considered whenever you doing your dry run and you're setting that screed up. Is if it fills that thing up with water, that might get more deflection in that screed.
I'd say, is it toward the end of the truss? Or is that?
Yeah.
Okay, probably ought to be close to the leg. So it's, I mean, if you put it out in the middle, you got that weight on there, and as you go forward, it's getting lighter and lighter as you pump your water out. You wouldn't want it out in the middle of the truss. This is one of those situations I was talking about earlier. See where he's running his rail? He's up on top of the, this is probably a latex overlay. He's up on top of his rail on this side. On the other side, I'd say you got a pretty good chance he's got his saddle sitting on top of the old deck. So this is the case where you'd have those two legs the same when you start off, and these two legs back here the same when you start off. All right, what's going on here? Any problems? What? He's got, that's a possibility. Why do you say that? It is. And that's one possible cause of that. But in this case, I think it's because that big loaf of French bread he's got right here. He's pushing a whole lot of mix with those rollers. And I'd say he's pushed so much, it's run all the way out the back, and that's what's left that ridge. But you can do the same thing by not having those drums set right. If he had them set flat, that's what you'd see. If you pour this wrong direction, I mean, if you have a finishing pass going the wrong direction on a skew, you're going to see that a whole lot worse. Those are some of the causes. So you can look at it and say, okay, maybe this is what's happening. And it's hard to see on this one, but it's also leaving kind of an open finish on it. So what do I do in this situation? Same answer as a while ago. Looks like he needs to lower those augers a little bit. If it was like you said, and he had it set up flat, if I got a good amount of concrete and it's finishing fine, I already told you, if it's finishing good, leave the man alone. But if it's finishing good but it's still leaving this roll, what could you do to fix that? Raise those back legs up a half turn, see what happens. And that's all we're after right here. We're looking for tools to help us if things start going wrong. We can know when we see him make an adjustment, we kind of know what that's doing. And if things are going wrong, we got an idea of what may be going wrong. This one actually looks real good if you can see it. I told you a while ago, the ideal situation to keep talking about that we, of course, are never going to see. We got the majority of this drum wet. The last little bit of it's dry. We're getting the maximum amount of finishing area out of that drum we can get without having it touching all the way. Because if it's touching all the way, it's leaving that little ridge we just looked at. But you can, a little clearer picture of this. This one looks like it's doing pretty good. All right, what we got here? You can tell, it's especially obvious if you look at the work bridge versus the screed. This one's on a pretty nasty skew. Kind of hard to tell just looking at the truss. I mean at the screed. But if you look at the difference in it and the work bridge, it's on a pretty bad skew. When I was talking earlier about you get less finishing area out of your drums as the skew gets worse, I'm on a 90-degree of that light right now, and you see how big the shadow is. When I start turning on that skew, it looks like my shadow is getting shorter and shorter. That's your effective finishing area. And the worse your skew gets, the less finishing area you get. That's when you need to start worrying about how much, is he advancing too much? The sheet we saw a while ago, which we're going to get back to here in just a minute, says 3 to 6 inches per pass. The worse the skew is, the less that advance should be. What's going on back here? When I first started, every bridge I saw, every deck pour I saw, finished it, then come back, somebody had a bull float, went all over the thing, come back with a broom. Is that what we want? I don't want anybody touching that deck that does not have to touch it. I want that burlap drag to be the last thing it sees until we put the wet burlap on it. The only time we ought to be back here on the work bridge is if something goes wrong. If we have a bobble or somebody falls off a work bridge and makes a mess and we have to go back, and we don't need to be back there. The more we touch it, and the more likely we are to get something wrong. Let's set the machine up right to start with. Spend the time making sure that we got that thing set up right to start with, and then don't touch it. This one, this looks like a latex pour. We're running on top of the rail out here. We're running on the old deck out here. We've got this green mess in the pan where they're giving a little extra weight. We got a latex pour. This is also one where we've got a mister. Now, talking about misting this deck. Where do we want that to happen? What about back here? Everybody happy if we're adding water back here? What about up here? What about in here? They can add water back here all day long. I don't care, as long as they don't add so much they make a little stream and run my grout out of the top of it. They can stand back there and just hose it down all day. I don't care. I don't want water going in up here. What happens when we add water in here? What is it doing? Where's the water go?
Concrete.
What?
In concrete.
It gets finished in with that top 1/4 inch. Now when we do that, what have we just done? We have raised the water cement ratio. When you raise the water cement ratio, what happens to your strength? It goes down. We have weakened the top 1/4 inch of that mix. Now what does the top 1/4 inch of that mix turn into in a few weeks? Huh?
Riding surface.
The riding surface, but the top 1/4 inch specifically turns into grooves. So we have just weakened our grooves. Have you ever walked out on a deck after you put traffic on it and seen where the grooves are popping off? That's a good culprit, right? That may be it right there. We've added water, which has been finished into the top surface, which made our grooves weak, and they're popping off. They may have to add a little bit in there, but I mean, I had one contractor that had this lady that worked for me. That was her job. She had a pressure washer out there, and she was like a kid with a water hose. And it got to the point where I finally went and I took the handle away from her. I said, "You can have this back when I think you need it." But the more we add out here, the worse it is. And when you start seeing these, this finishing pass and it's flipping up all this thin stuff, you've added too much water. The only thing misting is supposed to be doing is we are controlling the humidity of the air above this mix. That's the theory behind it. We're not adding water to the mix. We're making sure that the humidity is high up here in the air to keep this from drying out, to keep from getting shrinkage cracks. We are not supposed to be adding water. All right. Skewed decks, super elevations. Our friends in roadway design do some mean things to us sometimes. Went to a plan inspection a few weeks ago, and everybody's going around roadway, hydraulics, everybody's talking their stuff, and they finally asked me if I had any comments, and I said yes. I want you to go back and put a spiral on this deck. And they give me the funny look. I said, you got a vertical curve, you got a horizontal curve, you got a 50-degree skew, you got a crown. You can't screw it up anymore unless you put a spiral on it, so suck it to it. And somebody they said that sounds like Days of Thunder. He said, I want you to go out there and hit the pace car. It's the only thing you hadn't hit. But skewed decks, we don't like them, but we're stuck with them. The problem we run into is when we got a skew in the crown. That's one of the big problems. All right, what's wrong with this picture? Hmm?
The screed is not on the skew.
The screed is not on the skew. What does our spec book say? Spec book says you got a 15-degree wind on each side of 90. From 75 degrees to 105 degrees, you can run it like this. Below 75 degrees, above 105 degrees, you've got to set up on the skew. Why? What's the point in that? Well, let's look at what's happening right here. This setup right here. What's going on over here with this girder? Huh? It's deflecting quite a bit. What's happening out here on this girder? You don't even know we're pouring yet. If you've done your dry run and got it where your dry run passed, I'll guarantee you start doing depth checks and you're going to start having trouble. You got a lot of deflection coming out over here, none coming out over here, and that is not what we want. Even if we had allowed him to do this, even if we had allowed him to pour on a 90, what should we be seeing right here? Huh? Loading on a skew. This concrete should have been loaded on a skew. What you normally see, though, is if you've got them loaded on a skew and set up on a 90, it's just, I mean, it's a, you don't notice it if you're doing it yourself, but as he goes around through there, he starts loading it off right back here, but as he goes further and further, he starts coming around on a 90. It's just, you don't notice it, but you do it. What we need to do, you got 10 points lined up on your skews as you go out through there already. Take a can of paint, go out through there and draw a line across your 10th points. That gives you a good visual reference, and you can make sure that he's keeping that thing loaded on the skew as you go out through there. But when you do that, then you've got this one deflecting like this one is. Still not a good situation though, because where's your screed riding? Yeah, we've got it deflecting the same, but this one, the screed's riding where it's deflected here, and it's deflected off the ground over here. So we want it set up on the skew. You may run into situations where it's such a wide pour you can't get perfectly on the skew, but you get the best you can out of it. All right, what's happening here? Anybody see any problem? What?
Loaded way ahead of the...
He's got a half-acre mix out there he can't even touch it. Why is that a problem? Why is that a problem?
Dries out, time...
Oh, John.
It can dry out, it can flash set on you, you can have breakdown. You look around this area, looks like this guy's been vibrating. What's this? Because it looks nice and shiny. These works from grout up to the top. What's this mess right here? Huh? Why does that look rough and this look good like where it's been vibrated? Partially. What's those guys? What's that row of guys? I don't see where they're at here. Something's wrong. Guys raking. They've been raking back a whole lot of mix right through here because they had too much mix. We talked earlier about you're supposed to have about a half an auger height of mix being pushed by those augers. What controls how much mix there that you've actually got right there? Him. However much he puts out there controls how much mix that the screed is trying to push. The further he gets away from here, the harder it is for him to tell how much he is actually putting out there on the deck. And you end up with stuff where they're raking themselves to death, they got too much mix out there, or they got a low spot and he has to swing back up in here and add mix again. There's another thing that can happen by being too far away. How far should he be away? If you look later, since it's such inspiring reading, you can go through the pre-pour meeting checklist tonight, and it'll tell you how far, it'll have a question in there about how far ahead are you going to load that mix. What do you guys like to see? What do you think, Aaron?
4 or 5 feet.
3 inches.
A few feet before you can reach back in there.
What I like to see is I'd like to see that guy with the rake be able to reach that roll without getting too awful much concrete on his foot. And reach out there and pull it back. That way, this guy can kind of tell how much mix he's got in there. He doesn't get ahead of himself. You don't go stomping through it too much. What we want to see in the perfect setup is we see trucks rolling in consistently, the pump never shuts off, and the screed never stops moving. It's all one continuous operation that moves all day long, but we don't ever see that, do we? But
Any guy reported, deck we're using belt conveyors? Ever seen those still pumping it, you get, seen the belt conveyor, 4-wheel-a-day belt conveyor, and our operator was, he's Jim up. He knew what we wanted, and there was 2 guys with concrete hose working concrete, and they didn't hardly ever use it. It's one of, the best concrete place in Dickville. That guy, he just placed it, you're not pumping it, running out big wads, and, a guy trying to place it. That conveyor's, the trimming off the conveyor come down, he just placed it nice and smooth, kept about that far in front of the screed, and he could regulate that conveyor. He's a good enough operator that there's very little that's pushing up, dragging back, pushing up. Most time when the guys went up there and done it, they thought they needed to be doing something, And I took the pressure washer, like Cameron said, took it away from the guy and gave it to the foreman, tell him, I'll tell you when you can use it. It worked out good deck for him.
talking about raking, the guy on the very end out here and this guy right here, when they're raking, we've already talked about that screed's pushing up a roll of grout. When you get to the end of the pass, there's a roll of grout left there on that finishing pass. What does he do with that? It's nothing but grout. There's no aggregate in it. What I don't want to see, and I've seen this a few times and jumped all over somebody, you'll get somebody that's a little bit lazy and they'll turn that rake up sideways and they'll dig him a little trench. And what they're thinking is, as that pass comes across, he's going to fill that little trench up with that grout and I won't have to rake it. No, we don't want that. You're putting nothing but unconsolidated grout in a strip right down your gutter line. If you see that, stop them. If you see them out here when they're raking and they're digging down below the grade the screed's cutting to, stop them, because it's going to do the same thing. It'll just fill that space up with grout, nothing but grout. We don't want that. Anything else here you like or don't like? Okay. Go back to this. You got that on that, I think it's that 2-page handout. Anybody ever used a skew bar kit? What do you think about it?
They can work very well.
Can?
Yeah, can.
Can.
If the screed's set up properly.
Yeah. I've got some contractors I finally got talked into using them, and the ones that I've talked into using them, they like them. And
Yeah.
it's high-tech piece of machinery. I'm telling you, it's 2 pieces of channel with a bunch of holes drilled in them. All the thing is doing is moving where your wheels are at. Now, if you've got this situation right here, and Roadway Design's been mean to us, and they've given us a crown deck with a nasty skew on it, how do you get that crown set in here? What have you seen people do before? Well, let's say we just go in there, and we break that screed truss right here or right here, and put the crown in it like that. If you do it like that, you can stand back to the side and watch your drums and your augers. If you do it like that, you got your drums set right, and as you're making this pass over through here, when they cross that crown point, the front end of the drums are going to tip up like this. And as you go back across, they're going to tip down like this. What that's doing is monkeying with you trying to get good grades on this. If your front end is down lower over here than it is over here, then imagine what you're going to be seeing when you start doing your dry run. And when it's tipping like that, imagine what's going on with these augers. They're lower over here. They're not allowing as much mix back to your drums. You cross over here and they tip up and allow a bunch of mix back to your drums. You have finishing problems. So I asked a guy one time, first time I ever thought about this years ago. I said, what if you, let's put our brake and the crown over here on this side, right here. And we'll put the brake and the crown over here on this side. Actually, we tried some other things. We're going to straddle it, all kinds of different stuff. But if you put a crown brake here, and just leave your bogie normal, what happens when you cross center line then? Two front wheels are coming across through here. This one crosses the crown point, and then this one crosses the crown point. And right after that, this wheel crosses the crown point, and then this wheel crosses the crown point, and it goes across there like a little bucking bronco, and it's doing this mess. Either one of those things, what is happening, besides what I just told you, it's also rounding the crown off. You don't end up with a nice sharp crown, you end up with this roll. And it may offset it from one side to the other of your actual center line. Another thing it's possible to do is when it takes this tip over here and goes down. I spent 3 days with a poor old contractor in Wilkesboro one time trying to figure a Gameco out and make this scenario right here work. They finally just called a guy from the company, and he came out and wasn't able to help them either. They ended up chewing the header up when they hit this header out here on the end, and ended up with a big old patch that's still there to this day. So what's the purpose of this thing? What we're going to do is we're going to do like we just said. We're going to break the rail, the carriage rail over here right there, and put our crown in there. And we're going to do it over here on this one. What this skew bar kit is doing is it's just shifting where your wheels are at. It's shifting these wheels this way and these wheels this way. And what happens when you do that, these two front wheels cross that crown point at the same time, and these two back wheels cross that crown point at the same time, and you get a nice sharp crown like you're supposed to, and it makes your dry run much easier to do. You end up getting much more consistent results, and because you don't have that bogey flopping back and forth like this, you get consistent finish on this side of the crown and on that side of the crown. And this is, you see right here, and used to, Gameco didn't have one. That was what was the problem with that board. Now Gameco has a skew bar kit that they can get. Bidwell's got one. They also have these special length inserts that you can get since you want your crown to be here and here. Most contractors aren't going to do that. They don't want to have 4 or 5 of these sitting around the yard that they use once in a blue moon. What I normally see a contractor do is they'll go through and they'll take his carriage rail, the channel that is your carriage rail, and they'll cut partway through it with a hacksaw and make it to where it'll break at that point. That's fine. This slide right here is showing one of the special length inserts, and you can see that right here is where the crown's broke. On this side of the truss, there's the opposite side. The crown's not broke there. Come up here and the crown's broke at that point on the opposite truss. So as you look down the crown line, you're looking through these two joints, and that's where your crown is put into this deck. Now, again, on this picture, which way are we finishing? Leading to trailing. We're finishing like this, and that roller grout ought to be on this side of my drums the whole time. Okay. If you look at this picture right here, you can tell a little bit more what I was talking about earlier. The worse your skew is, the less finishing area you're getting out of these drums. If I turn those drums around square, they'd probably look like it was this long. Another couple of things that you can see on this picture, the pans, which direction are they put on there? Not having anything to do with where that little bar's at or anything. They're square to the direction that this thing is traveling, not square to the drums. That's what we want to see. This thing right here, this thing here, and this thing here, they pivot. If you have it turned in the wrong direction and don't have it set up right, what you end up with is instead of the pan going back and forth across your direction of travel, you end up with one corner of it ahead of the others. And I've seen several problems come out of that. If your consistency is not very good and you're letting them add too much water, which you shouldn't be doing, and maybe run a little trail of grout off each corner. I've also seen, that's where I was saying I've seen one get tipped up in that corner, get caught in that mix and go through there like a ski. You get a better finish out of it if you get that thing on a square like that. Same thing goes for your burlap drag. It goes on square to the direction it's going to. If you don't, it'll get bunched up and get wrinkled up, and it'll start leaving marks as you go back and forth across the deck. This is a picture of that high-tech device I was talking about. There's your skew bar kit. Big piece of channel, bunch of holes drilled in. All it did was took, right there's where the wheel that's here used to be, and it moved both the wheels down in this direction. Make sure you get it on there in the right direction though. I mean, make sure you shift your wheels in the right direction. And the easiest way to do that is you're standing on the crown line, looking down the crown line, and as that screed crosses, the two front wheels ought to cross at the same time, two back wheels ought to cross at the same time. If that's not happening, you don't have it on there right. What the specifications say is the contractor is supposed to give us the proper lines, grades, and everything else that we're looking for. It doesn't say that he has to use this, but it's about the only way you're really going to get what we're looking for. And I think after they use it once and use it correctly, and we get it set up right, and you see how much less work it is and how much of a better finish you get, I don't think anybody has a problem with using it. That's just a picture of it from the top. You've taken your wheels that were here and moved them out to here. And there again, you see how much your finishing area is reduced on this drum when you're on a bad skew. And you see, again, how he's got his drag pans on at the right angle and his burlap drag. I have no idea why that picture's in there. Now, what this is trying to show right here, if you get into a situation where you have got a bridge replacement, say you got twin bridges and they're very close together, and you're working on the first bridge or the second bridge, whichever, and you're on a bad skew, and you throw your phone in the floor, what happens on this other corner of the truss out here? If you're on a bad skew, it's sticking out further than this other corner. It's sticking out further than the rail. Here's your screed rail. If you're on a 90 degrees, that screed truss may only have to stick out like this. But if you're on a bad skew, this point's got to stay the same right here, and your truss may be sticking out like this. Now that may, depending on where you're set up, that may be sticking out here in traffic. There may be several solutions to that. You may have room enough on this bridge to where you can get them barreled over or something and take that danger away. But if you can't, if it's just you're stuck with a dangerous situation, there are end sections that are skewed for these trusses, and it just basically cuts that end of it off right there. And it's a skewed end section. So if you get into a dangerous place, there's stuff like that available.
Stage construction is always, always something happens when you're on that inside construction joint. About that screed overhang. And we've taught structural design roadway about trying to give us, trying to get that room in there whenever you're up against that, existing line of traffic. We're trying to get that room in there. And detour bridges and other things. A lot of times they won't squeeze them detour bridges in on top of that existing bridge, and it's tough to do it. We try to look at it, but strange things happen whenever we go through roadway design.
While we're talking about that, on stage construction, your stage 1, stage 2. If he doesn't have enough room in between those girders right there to put an overhang jack in, what do you see happen? He's got to have this formed in for his closure port. Where's he going to be running his screed? Huh? He's not poured phase 2 yet. Where's he going to be running that screed rail? He's only supposed to pour out to right here.
On that girl.
Huh?
On that girl.
We don't want to see the screed rail running right here. This deck has already deflected all it's going to, and it's going to monkey with your deck thickness and your setup over here if he tries to ride in a screed right here. We don't allow that. We don't allow him to form this up and have his side form out here somewhere and the screed rail running out here, because everything is going to pivot. This has already done its deflection. This stuff is going to pivot like this. You're not going to get the same amount of downward motion at this point where your screed rail's at as you would over here. What we want to see is something independent where these are not attached and he can make his own jacks, whatever, or we want to see him running his screed rail on top of this girder, and you can set it up to where you can run that rail on top of that girder. Then we don't care if that form's going down at exactly the same rate. He can go ahead and attach this stuff, but your screed rail is doing what your girder's doing. That's what we want to see. Little side note. Okay. Now, got a couple more things to go through here. Continuous for live load. These are where you have got ash toe type girders. You're pouring them all together. You got a big old diaphragm right here. And the ash toes are just the precast concrete girders. You have a pour sequence. Now, a lot of this information also pertains to where you've got pour sequences on continuous steel. Same ideas that I want to get across to you right here. You got a pour sequence in those plans. Stick to it. Unless you talk to the resident, the area bridge guy, or structure, somebody, you stick to that plan. The purpose in this, we got pour one out here, and we really don't care which direction that they pour one in. It doesn't have an arrow on the end of the line thread. Pour two, it'll show you pouring in this direction. And pour three, it'll show you pouring in this direction. Now, which direction do they usually end up pouring? Pour one. Usually going to see them pour it in the same direction as these two guys, because if they pour it in this direction, then when they get out here, they got to flip their bogey around and set the screed up. So he's normally pouring out through here. When he gets out to here, he's stuck, probably, isn't he? Huh? If he loses it with the crane, you get back out here and he's got to do his dry run again, because it may have, he can do that. It may have jarred something around. What is the official decision that the department has made as to when he can walk this screed back across that pour? What? That's one option. I don't like that option. That's just a big argument waiting to happen, isn't it? Because my initial set and their initial set and your initial set is probably three different things. What's the other option? He's got to get a certain strength, which happens to be 1,500 pounds. If he's got 1,500 PSI, he can walk back across it. The reason we don't want him walking back across there, he's putting that weight on those overhangs. And if we just got an initial set and he puts the weight on those overhangs, he may cause a crack out there outside that exterior girder. We don't see that. I don't like the initial set stuff because it's always going to be an argument. And every single part of this pour has, if you've got to not have achieved initial set anywhere in this concrete before you can do that. And that's just an argument waiting to happen.
The concrete on the bottom may be set. It may be set in the top, may not be set. You stick your initial set checker around in the top of it, and it says, oh, it's good, but on down in there, it may be a set.
I had one fella said, what is your definition of initial set? I said, it's right here. Now, the right way, the way we want to see this done, he pours this one, we don't care which direction he goes. Then, when he does that, the deflection comes out of this span. I'm giving you the reason behind this so you can get in your head if you ever see it going wrong. We pour that one, deflection comes out of it. Then we pour two in this direction, and deflection comes out of this one. What we're doing right here, we've already got the deflection out of this side. As we're pouring, going across through here, the deflection's coming out of it. By the time we get out here, he's going to be partially filling that up as he goes, but by the time we get this diaphragm done, all the deflection is out of this span and this span. What's the result of that? Yay, no cracks right here, hopefully. Does the same thing over here. Deflection's already come out of this one, and then when he pours this one, we're getting the deflection out, and by the time he finishes up out here, this is still green, and we've we've already got all the deflection out of the adjacent span. Same logic applies to plate girders. All right, let's say we do it the wrong way. He comes through here and pours that one, but he pours it in this direction, don't want to turn his screed around, so he's going to do this. What happens in that situation? We start filling this big old diaphragm up right at the beginning of the pour and start getting all this filled up, and that takes some time. And as we pour, we still don't have the deflection out of here when we've got this finished off. The deflection's coming out as we go across through here, and we may end up with cracks right here. Very good chance of it. So that is why you've got the directions that you've got, and you need to stick with it. You'll often have requests to combine pours, and they'll say it's only 50 yards between these two pours or 80 yards or something. I want to combine these two pours. I would advise you against that. You can talk to your resident area guys, whoever else you want to. They will make that decision with you. I had the only time I've ever allowed that. I had much of my own. I made a deal with somebody and said, "All right, you've got a brand new street here. We're going to go ahead and do that." Told you I'd let you do that. I was afraid the old one would break down, but you got a nice new one. And they started off and everything was going great. Concrete plant broke down. If you break down at the wrong time, you're going to end up with some cracking somewhere. Well, you want to minimize cracking. So, moral of the story is, never allow the contractor to change the pour sequence unless you have thoroughly discussed it with your area bridge guy and your resident. They may want to call structures and talk to them about some other things to make sure that we're doing the right thing. It's not something you can't do. I've done several of them recently where we've reversed them. Aaron brought up yesterday, if you get into a situation where, we showed where the conflict was at between the finishing on a skewed deck, whether you're finishing from low side to high side or high side to low side, and whether you're finishing from leading edge going back, you may be able to reverse the pour sequence and get it to where you're finishing from low side to high side and finishing from leading edge to trailing edge. But don't do that without checking. Make sure everybody understands the implications of what you're doing.
And Cameron's trying to explain the reason why the pour sequences are set up the way they are, so you get your deflection out before you pour over your vents, and it applies to the concrete girders with the big diaphragms, or with your continuous steel girders where it's rotating. But we want you to understand the reason why, so that, because I had a job recently where there was a planned error in the pour sequence, and it wasn't caught, and they poured over top of the vent diaphragm before they poured the adjacent span, and when they put that deflection on it, it cracked over top of that, over that vent. So if you understand why it's set up the way it is, you might be able to pick that out. Hopefully, one of us will be looking at it, we can catch that too, but just kind of try to understand the reasoning behind why the pour sequences are like they are.
The big thing you need to remember is on whether it's continuous plate girders or whether it's this, the end of the pour is when you're just getting over the vent. You just cross the vent and then there's the end of the pour. You don't ever want to see it where you start off crossing the vent and then you end up the pour out here somewhere. That's where you run into trouble. The vent or the big old diaphragm or whatever, that's supposed to be right there at the end of the pour. And if you see it any other way, question it. All right, a couple more things, and then we'll go eat lunch early. In a curve, what's happening when we got a curved bridge? Roadway Design's been mean to us again, and they give us this curve in the deck. What's happening as he moves his screed across that deck? What better be happening is that side right there better be moving faster than this side. Because if it's not, he's jumped the tracks. And he may be going out through here like this, just catching up and falling behind. We don't want to see that. We know we've got the old surveying book we can pull out, and we can find the arc distance for this side of the curve and for that side of the curve. Apparently on this one, it's 400 feet on the outside and 350 feet on the inside. So this side of the screen's got to be moving faster than that side. We like even things. We like stuff to be smooth and flowing. We don't like abrupt transitions. Just like on the little drawing I showed you, I want everything to either be a little bit higher or a little bit low. I don't like this stuff going back and forth. So we want this to be even. How do we do that? Well, I figured out those distances. I'm gonna go around through there and I'm gonna mark my rail every so often. I'm gonna say, I'm gonna divide that number right there by 10 or 20 or whatever I wanna have my little increments be. I'm gonna divide this number right here by that same number of increments. And I'm gonna go out through here on my side form or my rail with another can of paint, and I'm gonna start marking. So what I should end up with is, you know, let's say I just use 10 to make it easy. Every 35 feet, I'd have a mark. Every 40 feet, I'd have a mark. Or you could make it half of that, or whatever you want to. But I've got marks corresponding on each rail to keep me going correctly, and I don't have any of these bobbles as I go around through there. And hopefully, see them going around through there, and they end up hitting the header just right. So I've got marks on my reinforcing steel because I've got a skew and I want to keep him loading on a skew. I've got some marks on my rail right here because I want to keep him going evenly around that curve. I want him to basically stay on the skew all the way around through here. Now, Roadway's been really mean to us, and they've thrown in a transition on our deck. They did what I said, and they put a spiral on the deck or something on that bridge I was talking about. And we've got a transition from the first of the deck on out through here from an 02 to an 06. How do we deal with that? We go out through there and then all of a sudden somebody remembers, oh crap, we're supposed to be flattening this out, and they drop in the middle of the screed all of a sudden, and you end up with those quick transitions that we don't like. We want long, smooth transitions. We want things to be even. So what am I going to do about that? How do I get from here to here? I get from there to there by going to the middle on that manual crown adjuster, and slowly I'll let the middle down and it starts flattening out. And I'm going to go from this 02 up to a 02, constant 02, and then I'm going to start tilting up the rest of the way to this 06. To get from here to here is the important part I want to talk about first. I know right here I'm an 02. At some point out through here, which I can figure out from my plans, I'm going to be basically a reverse. At that point, I'm going to go out through there and take that distance, and I'm going to break it up into increments, just like I did this right here. I'm going to take another color of paint, and I'm going to mark it. And I'm going to say, okay, each time I pass one of these increments, I know he needs to be out there cranking on that thing. The more increments you put in there, the smoother the transition's going to be. So that as you go around through here and he's cranking on that thing, you're just slowly doing like this until you get to the reverse super. Okay? And so we've got 3 different colors of paint out there. We've got a stick in our back pocket with a T on the end of it. We've got a pay record book in the other back pocket, or workbook. The guy that's the head inspector is a busy guy on something like this. He needs to be out there, not back at the truck testing concrete or with a thermometer or anything else. He's got plenty to do. So just remember, we're trying to make these transitions even. And if you have any trouble with it, call that's our area bridge guy. Anybody got any questions on any of this? Yes, sir.
Earlier, you mentioned setting your off you build up with Preacher.
Yeah.
And of course you got overhang, you got jacks over there.
Yeah.
And you ever having problems with the jack settling when it's loaded with concrete to mess up your right?
The first time, well, we're supposed to be having form settlement figured in there, which is usually we'll use an 02 quarter inch. The first time I ever I have skeletonized this presentation. The guy from Bidwell originally gave this at one of the engineers conference, and I got it and altered it a bunch to start doing here. And he said one of the things he does is, especially if they're building their overhangs and everything out of new wood, first thing he does is he'll take several passes back and forth from one end of the bridge to the other with that screed, just trying to get some form settlement out of it. But when we go into the construction manual, we've got stuff in there telling us that normally right at the end of the deck, right at the caps, it'll be stiff. Your overhang's going to be stiff legged somehow. You don't really have to worry about that there. But as you go out through there, when you're out in the middle of span, you're gonna have some form settlement, and that should be factored into the calculation for setting your overhang rates. When you're preaching that thing, we've got our girder. Here's our overhang. Here's our side form. What the deck is actually doing. We've got our deck coming across through here to the gutter line. It flattens out underneath the wall, and this is where our barrier is. Didn't draw that terribly good, did I? And here's going to be our side form with our. Okay. When we're figuring that, we're figuring basically, and you go through the construction manual step by step for this, and you can figure it out. We know where our elevation's supposed to be right here. We've got bottom deck elevation right here, and that's how we're figuring out our build-ups. We can run, and we'll say we're maybe on an 02 right here. We can run that over 2 to here. We know what the elevation was there, so we know what the elevation is here by running that 02 out. That elevation is going to be the same elevation as this. And we know what that exterior is supposed to be, so we can measure down to that. But we're also going to add to this elevation we got right here 200ths to account for that form settlement. Because yeah, when you get out there, all that weight gets on it, something's going to go down. It's going to settle some, but that's where we're going to account for that. What I used to see a whole lot, that's one of the things I don't see anymore that I'd like to see, is paddle tails. You would have the old inspectors would get out there, and they would, if they could reach it, you'd see them, they'd go and they'd hang maybe a plumb bob or a rock or something on a string from one of the bottom flanges. And directly below that, if they use plumb bob or something, they'd drive them a stake. And they'd measure between plumb bob and stake. And sometime through the core, you'd see them slip off and go underneath the deck, and they're measuring to see if the camber's coming out correctly. And they may do the same thing out here on the overhang to make sure that's done correctly. Anybody else?
22.
22.